Today this video is dedicated to the concept logarithm and the rules and laws associated with this. Because the logarithm is very frequently used in the study of physics, chemistry as well together with maths, this is extremely important to understand the basic concept of log. So let's start. So first of all, we would like to define logarithm. So let a raised to the power b is equal to c, then b is called logarithm of c with the base a. I repeat, if a raised to the power b is equal to c, that is, if c is a number which may be expressed in the exponential form as a raised to the power b, then b is called logarithm of c with the base of a, and it is written as log c base a is equal to b. So we say that b is a logarithm of c with the base a. Log c base a is equal to b. So this is the basic concept of logarithm. This is the definition of logarithm. So we may say that this is a way to express a number in exponential form other than the conventional form. This is conventional form, and this is a typical method, or we can say a typical way to express a number in exponential form. So now there are some rules which are very useful in physics, chemistry and mathematics as well. So we would like to explain or discuss those rules now. So some important rules, some important rules of logarithm. The first rule, which is called product rule, that is log m into n base a is equal to log m plus log n with the same base. For example, log 6 base a may be written as log 2 into 3 base a. So according to this rule, we may write them as log 2 base a plus log 3 base a. And we are using a in the formula as base of log, and in the example also I have taken base as a. So it doesn't mean that every time it is necessary to take a as the base of log. You may take any number. The necessary condition is whatever you take base of log here, the same base should be taken here on the right hand side. It may be b, it may be c, it may be k, it may be lambda, it may be 10, and in numeric values also. So this is the law. And always remember, as you see, this is the rule, log 2 into 3 is equal to log 2 plus log 3. So remember, log 2 plus 3 base k, whatever you may take, is not equal to log 2 base k plus log 3 base k, because this is very common mistake committed by the student. They used to think like this log is distributive over addition. So as xa plus b may be written as ax plus bx. In the same way, the students used to think that log is also distributive over addition, and if we open up this bracket, the log will be multiplied inside having the value log 2 plus log 3. This is not true. So be very careful about this mistake, because if log 2 into 3 is equal to log 2 plus log 3, how could it be possible to write log 3, 2 plus 3 is equal to log 2 plus log 3. So this is invalid. This is not true, because the law is this one. So remember this. Now, this second law, which is called quotient law of logarithm, that is log m upon n base lambda is equal to log m base lambda minus log n base lambda. If the number is given in the form of division or fraction, so that is written as the difference of the individual logarithm of numerator and denominator with the same base. This is the second law, which is called quotient law. So for example, log 2 upon 5 base 10 may be written as log 2 base 10 minus log 5 base 10. This is second law. Now we come to the third law. Third law is log m raised to the power n base lambda is equal to n log m base lambda. This is called exponential law of logarithm. And what does it mean? If the number whose log is to be taken is given in exponential form, something raised to the power something, then the power or index of the exponential form jumps out. It jumps out of the log and becomes the coefficient of log, and only m is left inside. So it becomes n log m base lambda. For example, log 625 may be written as log 25 whole cube, 25 square. And again, if we write 25 as 5 square, so it becomes 5 raised to the power 4. So log 625 may be written as log 5 raised to the power 4, and according to this rule, this power jumps out of this log and becomes 4 log 5. This is called quotient law exponential law of logarithm. Fourth law is log m base n may be written as 1 upon log n base m. What does it mean? It means if we take the reciprocal of any log, its number, this number is and base of the log are interchanged. The number becomes the base, the number whose log is to be taken, that becomes base, and base becomes the number whose log is to be taken. So we may write 1 upon log n base m. Base m. That means if a log is shifted from numerator to denominator or denominator to numerator, the number whose log is to be taken and the base of the log are interchanged. For example, log 2 base 3 is equal to 1 upon log 3 base 2. Next law next law, that is the fifth law, is log m base m is always equal to 1. It means when the number whose log is to be taken and the base of the log are identical, the value of the log is always equal to 1. So, for example, if we write log 2 base 2, that is equal to 1. Similarly, log 95 base 95 is equal to 1. And you may take any number, but the same number is taken in these two places. The value of log is 1. Sixth law, log m base n may be written as log m base lambda upon log n base lambda. What does it mean? Log m base n may be written as log m, that is the log of the number whose log is to be taken with the base n with a different base lambda, divided by the log of the base with the same base lambda. That means we may take the common bases of both the logs, and log m base n may be written as log m upon log n. For example, log 10 base 5 may be written as log 10 base e divided by log 5 base e. You may take any base, whatever is required in. So if there is no need of taking any specific base, you may keep it blank. It means any base may be taken in this form. So this is sixth law. Now seventh law is log 10 base 10 is equal to 1, log 100 base 10 is equal to 2, log 1000 base 10 is equal to 3, and so on. What does it mean? If we are taking log of any multiple of 10 with base 10. So its value is equal to the number of the zeros in that multiple of 10. The multiple of 10 means 10, it may be 100, it may be 1000, it may be 10,000, it may be 1 lakh, 10 lakh, so and so. So there is only one zero in 10. So with the base 10, its value is 1. In case of 100, there are two zeros. With the base 10, its value must be 2. And if we take the log of 1000 with the base 10, its value is 3. So this law is very frequently used in physics. So next law is 8th law. This law is rarely used but very beneficial in the study of calculus and differential and integral calculus. This rule is used. So e raised to the power log a base e. If there is exponential form as e raised to the power log, log is in the exponent of e having the base e, then these two will eliminate each other. Only the number is left whose log is given in the exponent. So e raised to the power log e base a is equal to a. This is extremely important but very rarely used in maths. So these are some very important laws and rules related to logarithm, and I think nothing else is required to explain. So please let me know if you have any further query about a logarithm. So you may write in my comment section. I will try to create another video for that particular query. So thank you very much for watching this video. Take care. Bye bye.